I'm going to go through a study guide to go with Unit 2, which is two-dimensional motion. First, we're just going to talk through some of the key vocabulary words. So the first one is projectile, and a projectile is really anything in free fall, right? Anything that's being acted upon by gravity. So if something is falling, we can call it a projectile. It could be thrown, it could be launched, it could be dropped, it could be kicked, right? All of those things would indicate that something is falling, that gravity's acting on it, that it's no longer being supported by something else. And so all of those things would be a projectile. Now, trajectory is the path followed by a projectile. Okay, and it takes a specific shape, which is a parabola. And so if you think about either something that's launched at an angle or even something that is just launched horizontally, you're going to see that it follows this particular pathway, or it follows this particular pathway, which is half a parabola, but it's going to make that characteristic arc shape through the sky. But that actual path that it takes, we call that the trajectory. The range for an object is also known as the horizontal displacement. Another way of saying that is how far does it move to the side? When we calculate for this, we use d with a little baby x. I know that's kind of small, but you guys can hopefully see that. D with a little x is for the range or the distance in the horizontal direction. So, for example, with my projectile there, right, this would be dx, or the range. Or if I'm doing a horizontally launched projectile, then that would be my distance in the x direction. So those would be my ranges. Vertical displacement is another way of saying the height, or how far down. How far in the vertical direction. Okay. So if I was looking at this projectile, I could figure out the height, right? This would be the dy here. Or if I'm most of the time, right, we were talking about horizontally launched projectiles, and so the height would be like the height of the table that the object fell from, or the cliff, or whatever it is that the object is falling from. So dy is the vertical displacement, or the height. Acceleration due to gravity, right? We know this value is 10 meters per second down always. Okay, basically what it means is that this is how objects, how gravity changes the velocity of objects. And this changes the vertical velocity, right? Because gravity is acting in a vertical direction. All right, horizontal velocity, how fast something moves to the side. So we can have a horizontal, for something that's launched at an angle, we'll have a horizontal component of the velocity and a vertical component of the velocity. For something that's launched horizontally, we will only start with a horizontal velocity. All right, so for example, if we have our object here, it's got a resultant velocity that is made up of a horizontal component and a vertical component. The horizontal component is the Vx. Okay, if I'm talking about something that's launched horizontally, then the Vx is whatever speed it is that it leaves the table or the surface. Vertical velocity is how fast something moves vertically. All right, so again, kind of thinking about our example here, this would be the Vy. For something that's launched horizontally, it doesn't start with a vertical velocity, but once it gets here, it will have some vertical velocity, okay? So vertical velocity is the velocity in the up-down direction. And it is changing because of gravity. Okay, the horizontal velocity is staying the same. Okay, so horizontal velocity stays the same, vertical velocity changes. Resultant. This is like the hypotenuse of a triangle. It's the combination of two component vectors. Okay, so for example, if I had a component here and a component here, then this would be my resultant. Okay, component is like a velocity or a vector in one direction. Okay, so that would be a component, that could be a component. I can put two components together to get a resultant. I can resolve them to get a resultant. This would be like a horizontal component, this would be like a vertical component. All right, so when we actually, so thinking about those two concepts there, when we add vectors, here's what we're going to do. Let's say we have I move 2 meters east, so I'm gonna actually sort of draw it out. And here is our compass to help you remember your directions. So I go 2 meters east, then I go 12 meters west, and then I go 15 meters east. Okay, well, since all of these are just going side to side, all I have to do is add and subtract. So we say that 2 is in a positive direction, 12 is in a negative direction, 15 is in a positive direction. So I'm just going to do 2 minus 12 plus 15 is going to give me 25 meters. And which way did I end up at the end? I ended up east, so 25 meters east. So if all of the directional terms in here, east, west, east, if they're all in, we call this one plane of motion, right? They're all on this part of the axis, then all we have to do is add and subtract. But if we have a situation where they're going, we've got a vector, a component that is this way and a component that is this way, we can't just add and subtract. We're going to have to do something else. So here's an example of that. You row your boat at 9 meters per second north across a river that's flowing 4 meters per second east. Okay, so now you can see how we've got one component that's in this direction and one component that's in this direction. So I can't just add and subtract anymore, but I can do some pretty simple math to figure out the resultant. And I'm going to do the Pythagorean theorem. Now you'll notice how I drew these. I drew these what we call tip to tail. So I just put them together. The tip of my first component is where the tail of my second component goes. And so I just drew them in the direction that I was told. So north and east. And now to figure out the resultant, all I'm going to do is Pythagorean theorem. A squared plus b squared equals c squared. Remember, the only rule that you have to follow here is that c must be the resultant. Okay, so for this particular example, I'm going to say 9 squared plus 4 squared equals c squared. My calculator so I don't mess up the math here. So this is 97 equals c squared, and then I'm going to take the square root of both sides. So c is 9.85 meters per second.